Hello Lauren, Hannah, this is for you. Okay, we'll start the lesson. Okay, watch here. Since you have no questions regarding your homework, what I intend to do now is I'm going to take you through the process of the product rule. Okay, the product rule. If there's time today, then I'll go on to the quotient rule. So the key thing I want to teach you today basically is just the product rule itself. Product rule is not difficult to manage. Okay, but what comes after that, right? The manipulation, the algebraic manipulation. Whether is it you're dealing with search or you're taking out common factors, all that. That one is a whole different issue altogether. That basically depends on your ability to manage algebra. Okay, if your algebra, your foundational algebra is very strong, right, you will have no problems with the second portion of the lesson. Okay, which is just the managing of the algebra. So what I'm going to do is I'm going to take you through the process of product rule. Okay, that's the main objective for today. Okay, before we do that, let's do a very quick recap on everything that we have learned so far. Okay, so you will introduce the term-by-term differentiation. Okay, the textbook call it the sum rule, and the other one difference rule. Basically, just term-by-term differentiation. We are given ax to the power of n. Ax to the power of n, where a is a constant, n is a constant. So if I want to differentiate it, what is the general rule by the formula? What do we have? Casey, what do we have? A and then x to the power n minus 1. Very good. Okay, so simply all you have to do is just the power, bring it down and multiply, power subtract 1. That's all. Power bring down, power subtract 1. Am I right? So other than that, you also introduce to a situation. Okay, we worked on a few questions yesterday, so I cleared a few misconceptions regarding the use of the chain rule. So to use your chain rule, you must recognize over here the bracket, involves a bracket over here, and then there's an algebraic term. So over here, if I have to differentiate this, what do we have? So how do we manage this? What do we have? N ax plus b, then power subtract 1. Then what must you do into the what that you have inside the bracket? You have to differentiate it. Okay? So you just differentiate what you have inside the bracket, that will do. And then you just tidy it up lah. So it's ax plus b raised to the power n minus 1. Okay, so generally, basically this is like a formula that we must remember. I took you through the process of the first principle regarding limits, what happens to the derivative, what happens to the expression when your h approaches 0. So please don't forget to look through your notes in case you have forgotten how to manage differentiation using first principle. Okay, so you must know all this stuff. So what I'm going to do is, okay, we'll try a few questions. Okay, we'll try a few questions. Then I will bring in the product rule to you. Okay, let's take a look at this particular situation. Okay, if I want you to differentiate this, given that y equals 2x minus 1 times 3x plus 2, how will you differentiate it? Okay, everybody try. Okay, thanks Christy. So over here, right, can we take a look at what Christy did? Okay, watch here girls, Michelle, watch here. Okay, over here, right, when you're given a situation whereby you have 2x minus 1 multiplied by 3x plus 2. Based on your current knowledge, what can you do? Okay, what did you do? So what Christy did was basically she just expanded this, and then she has 6x squared plus x minus 2. Okay, then after that, all she has to do is just differentiate term by term. So you differentiate 6x squared, 12x, you differentiate x, you have 1. Differentiate the constant, you have 0. So that's it. Okay, straightforward. Nothing difficult. Am I correct? Okay, I need you to check your steps. Okay, well, like what you did in your homework yesterday. Did anybody make this very critical mistake? Very important here. Your dy dx is down here. You have to check. From yesterday's lesson, I shared with you one very important learning point is where to write your dy dx. When to write your dy dx. You write your dy dx when you start to differentiate. Okay? If for the particular line you're not differentiating, then it might still just be y, The moment you start differentiating, then your dy dx appears. Please remember that. Okay? So over here, this is how we manage a very simple differentiation situation. Okay, but what if I give you something that looks similar, but I put a 4 here? What if I put a 3 here? What if? I want you to differentiate this. What can you do? What will you do?
Differentiate one first.
Okay? Okay, watch here. To differentiate a situation like this, okay, how do we manage this? Over here, we can do one crazy thing. What can we do here? What can we do? Tell you what can we do to this? We can do. What can we do to this? 2x minus 1 raised to the power. What can we do to it? Based on your current knowledge now, are you able to differentiate this? Can or cannot? Can, right? It's just a very painful process. But what can you do? Tell you what can you do? Any idea? Expand, right? Very painful. How do you expand this nonsense? How do you expand? Sorry? Public speaking voice. Binomial theorem. You can do a binomial theorem here. 5 terms. After that, what do you do? Sam, what you can do? You can expand this also, right? 4 terms. After that, what do you do? You expand every nonsense here, every nonsense. Then after you do term by term differentiation. But that, you know, is extremely inefficient. It's very time consuming. It's a lot of hard work, right? Not that hard work is no good, but this is very foolish. Well, you're really wasting a lot of resources, a lot of time just to do something, just to differentiate this. So how do we manage this? Okay, this is where I'm going to introduce this to you. You watch. I'm going to write it down over here. I'm going to write it down this rule for you. Okay, watch here. If you are given a particular situation, y equals to a product. Listen to me carefully. A product of 2 expressions. Both must contain x. Both. This one must have x, okay? Must have x inside, must have x. This one also must have x. Okay? It both must have x. When you're given a particular situation, an equation whereby y equals to a product, means must multiply, 2 expressions over there, both of them have x. In this situation, you can do what we call the product rule. The product rule. Okay, the product rule of differentiation. How do you do this product rule of differentiation? How do you do it? Okay, very, very simple trick. Just pay attention now. It will look like this. Okay, when you differentiate it, okay, the formula is stated like this. U, which is the first expression, then you dv dx, makes you differentiate the second one, plus you fix the second one, which is a v, then you differentiate the first one, du dx. This is what we call the product rule. Let me repeat this. When you have a situation whereby you have 2 expressions multiplied together, both must have x. Okay, then we can consider using the product rule. How do you do the product rule? Let the first expression be u. Let the first expression u, second expression is v. So dy dx equals to u. You fix your u. Differentiate the second one, dv dx plus v. Fix your v. Differentiate the first one, du dx. Is that okay? Can manage? Okay, what I'm going to do now is I will take this and then apply it here. Okay, watch. If I want to differentiate this, let me check the current situation. What do I have? What do I have? Can you tell me? Is this a product? Yes or no? 2 expressions, right? Both contain x. This one has x, this one has x. Am I correct? So I want to differentiate this. So how do I differentiate this using the product rule? It will look like this. So dy dx equals to, so over here, can everybody see the first one will be your u, the second one will be your v. See, this is a u, this is your v. Is that okay? So I fix my u. So right now, 2x minus 1 with the power of 4. Then I differentiate the second one. Differentiate the second one, what do I have? I have 3x plus 2 raised to the power of 2. Differentiate inside the bracket, I have 3. Basically, what am I doing? I'm applying the chain rule. Are you clear? Are you with me? Plus, fix my v, so I write this down. 3x plus 2 raised to the power of 3. Differentiate my u. How do I differentiate my u? What do I do? I use chain rule again, right? So 4, 2x minus 1 raised to the power of 3. Differentiate inside the bracket, I have 2. Is this line, do you understand how to manage this? Okay, today's lesson is simply just teaching you how to do this. This is not difficult. This is the product rule. Okay, just have to fix your u, dv dx plus v du dx. Is everybody clear? Okay? Okay, you take some time to copy this down. Then later I'll teach you how to manage the algebraic manipulation portion. Okay, so from here, right? So all we have to do is continue. This the first portion over here. This is your product rule. So u dv dx plus v du dx. Is that okay? Okay, can everybody say u dv dx plus v du dx? Everybody go. Go. U dv dx plus v du dx. So that is the product rule. Okay, so the first term is always a u, second one is v. So u dv dx plus v du dx. That is the key thing you must remember for the first hour. Alright? Okay, from here, right, what do you do? All you need to do is just take out common factor and then we tidy it up. So let's take a look. There's 2x minus 1 inside, the power 4, power 3, I can take out power 3. Right? There is 3x plus 2, power 2. I can take this out. So when I take this out, what is left? Okay, so you must manage your algebra carefully. So I'm left with 9 bracket 2x minus 1. Can you see? Because this one 2x minus 1 is to the power of 4, this 2x minus 1 to the power of 3. If I take 2x minus 1 to the power of 3 out, I'm left with 1. 2x minus 1. Okay? So then from here, this is plus. I took this out, so I'm left with 8. 2 times 4 is 8. Then 3x plus 2. From here, I just tidy it up. So 2x minus 1 cube, 3x plus 2 square. Then I have 18x minus 9 plus 24x plus 16. So this will be 2x minus 1 cube, 3x plus 2 square. 18, 24 is 42. X plus 7. Okay, this can be an answer, but a better answer will be factorize, take out the 7. So you're left with 6x plus 1. So this will be the answer. Okay? So notice this portion in blue, right, is nothing but just taking out common factor and then algebraic manipulation. You just have to manage, check your indices, make sure when you multiply them, multiply two expressions the same base, add up the power, check is correct. So line by line, don't make careless mistakes. Okay?
Yeah.
Okay, girls watch here. Okay, most teachers or tutors when they teach this particular segment on product rule differentiation, right? They may not zoom in straight to u dv dx plus v du dx to help you be able to distinguish which term is what term is which. So what most teachers and most tutors do is we use this particular the 4-box approach. Okay, 4 boxes. So what we do is we let this be v, right? U, this be v. So we write down. We say let u be x squared plus 1. So this is x squared plus 1. Correct now? Then we let v be x plus 3 to the power of 4. Okay, so this is what I mean by the first box, second box. Okay, we did this yesterday. So if this is u, then what is this? du, d what? X. So differentiate this. Okay, differentiate this. What do I have? What do I have, everybody? Come on, differentiate x squared plus 1. What do I have? Everybody talk to me, what do I have? 2x. Okay, the weird thing was when I walk around and I look at the solution, right? When you had to differentiate this, a lot of you didn't write 2x. You all wrote funny things. You all wrote chain rule version. You all did things like x squared plus 1, power now 1, 2x. You all did this. So girls, this is wrong. It's not chain rule. This is x squared plus 1 with the bracket here, right? If I just let you be x squared plus 1, right? It's like the bracket is redundant. I can remove the bracket. Can you see it's term by term differentiation? It's simply just 2x. So this is my third box. My last box is dv dx. So differentiate this, what do I have? 4x plus 3 squared and 1. So the 1 is redundant, right? So this is my fourth box. So in case some of you cannot visualize like me, you cannot see what I see, like go into the u v dv dx plus v du dx, my suggestion to you is, can you try this first, this approach, okay? Make it a habit, just write u v du dx, dv dx. But by the end of this week, by next year, we must check this off already, because exams, you know, in the short span of limited, the finite time, right? We may not have the luxury slowly write down things like that. You just have to know your stuff. Okay, but for now, because this is your first time experiencing the product rule, so it may be a good idea for you to write this down first. What's u must be du dx dv dx. Then you start differentiating. So dy dx equals to, then you write u dv dx plus v du dx. Maybe this approach is more, a lot more scaffolding, so you can do it slowly. Okay. So what is u? You write down x. Can I write like that? X squared plus 1. dv dx is 4x plus 3. Can I write it this way? Can I write this way? Can I write this way, girls? No, right? Bracket must be here. Is that okay? So u dv dx plus v, then du dx. So it's 2x. Okay, so now the next step is, okay, basically today I just need to understand this part. If you know how to do this, we made the lesson objective already, which is learning how to do product rule. Okay, the product rule technique. After that is your algebraic, your ability to manage algebra, how to factorize. Okay, over here, can I take out x as a common factor? Everybody, can I take out x as a common factor? Can or cannot? Here got x squared. Can take out or not? Cannot, because this is x squared plus 1, this is 2x. Is that alright? Yes. Oh, sorry, power 3. This is, yeah, sorry, my bad. This is 3. Okay, sorry, this is 3. Okay. So over here, what is the common factor to take out, everybody? What can I take out? Come on, what can I take out? X plus 3 what? To the power of what? Is it the power of 3 or the power of 4? 3. Take out the common one, okay? Honestly, what else can you take out? Other than this, there's one more. The number 2. There's a 4 here, there's a 2 here. You can take out the 2. So if you take this out, what is left? You're left with 2x squared plus 1. Okay, double check. 2 times 2 is 4. X plus 3 to the power of 3, x squared plus 1. Plus, I took out the 2, I'm left with the x inside. So I took out x plus 3 to the power of 3, so left inside x plus 3 to the power of 1. Okay? But the 1 is also redundant, only. So from here, we just tidy this up. So 2 bracket x plus 3 cube. And then this is 2x squared plus 2 plus x squared plus 3x. So this one will be 2 bracket x plus 3 cube and then 3x squared plus 3x plus 2. That's it. Okay? So, Ayong, you understand where? Okay. Okay, I'll take you through Shanae's solution first. Okay, so given a situation where y equals to 2x to the power of 4 minus 1 multiplied by 5x plus 6 to the power of 4. Let's check our condition for product rule. Can we use product rule for this? If we can, then we'll use it. If not, we'll think of something else. Over here, you have two expressions that multiply one another. Notice it's product and both contain x. So we can use the product rule. So let u be the first expression, u, then v be the second expression, du dx, dv dx. Differentiate accordingly, so this is really nice. Okay, so all this is correct. So now she will differentiate dy dx. So using the product rule, what is the product rule, Casey? Loud and clear. U dv dx plus v du dx. You must know this, like you know your own name like that, okay? But this whole morning we've been doing nothing but this. You must know this, okay? So u dv dx plus v du dx, plug in accordingly, factorize out, okay? Factorize out. So look at how she just plug in accordingly, then she just managed the factorization part. Let me check the factorization part. So she took out 5x plus, yes, this is correct. She took this out, 4 times 5. Actually, you can take out the 4 as well. Shannon, it's not wrong, but you see there's a 4 here, there's 8 here. You can take out the 4 if you want to, okay? But this is good. Then she just tidy it up only, that's all. Okay? Nice. Okay, over here, the next one, right? For this next question that I want you to that you have already tried. For this question, this is slightly different from the past 3 or 4 questions which you have been exposed to. Okay, what is the key difference? Jessica, what's the key difference about this question that's different from all those stuff that we have already done so far this morning? Contains surds, right? It contains surds. So there's a square root 3x squared plus 1. So let's check for the condition for let's check the condition to see if product rule can be used. So in this case, we have y equals to something times something. Notice something times something. Both of them contain x. So I use the product rule. So over here in this case, u is the first expression, v is the second expression. I differentiate accordingly. Okay. So over here, right, see now if you want to, you can simplify this. Put the half and the 6 here. You can tidy it up if you want to. So it will be nicer. So it will look like 3x over square root 3x squared plus 1 if you want to do it. Okay. So from here, she applied the rule accordingly. U dv dx plus v du dx. Okay, the approach that she used here is something that we have been doing this morning. Factorization technique. So she just factorized, take out whatever is common. Notice there is a 3x squared plus 1, okay, over here to the power of negative half, 3x squared plus 1 raised to the power of half. So what she did was she took out the one with the smaller power, okay? So 3x squared plus 1 raised to the power of negative half. This part you have to pay attention, okay, because let's check, this 3x squared plus 1 raised to the power of negative half multiplied by this expression will give you this, right? Let's check the other one. So this times this. So negative half, 3x squared plus 1 raised to the power of negative half times 3x squared plus 1 raised to the power of 1. Notice, we learned a lot of indices, okay, in your EMATS and AMATS. We multiply two expressions with the same base, we add up, we sum up the indices. So negative half plus 1 is indeed half. So I know this is correct. Then after you just tidy it up and then you get this answer. Okay, so this is an approach. She tidied the algebra part using factorization technique. Okay, the factorization approach. Is there another method? Okay, my suggestion is let's tackle this when it involves a denominator, especially if it has surds involved. My advice to you is we need not use this method. We can try a different approach. Okay, watch here. Let me write it up for you. Okay. Okay, watch here. I'm going to tidy up this part. This will look like 3x over square root 3x squared plus 1. Okay, look, the 6, the 2 and the 6 can cancel themselves, so 3x is here. So to the power of negative half means you bring it down as a denominator, half means you square root 3x squared plus 1. Am I right? Okay, watch now. I'm going to manage this without using factorization. Okay, but we just do it as if it is just pure algebra fractions. Okay, watch how I do it. So over here, so dy dx will be equals to u dv dx. So dv dx is 3x. Then I have square root 3x squared plus 1. Can you see? U dv dx plus v du dx. Okay, what just happened over here? You notice this looks kind of different from this. Why? Because I wrote it in its fraction form, in its rawest form. I wrote it this way. Look, this is the same as over 1. Am I correct? Okay, watch now how I manage the algebra part. When you want to sum up two fractions, in primary school you learn, you must always ensure that the denominator is they are the same, right? The denominators are the same. So in this case, this is over 1. What do you think I should do over here? What do you think I should do over here? Multiply by what? Square root 3x squared plus 1. Agree with me? Multiply this by 3x squared plus 1. Are you all with me? Okay, I multiply by this particular expression. Why? I'll make the denominator the same. Watch the magic now. So now my denominator, LCM, basically is just 3x squared plus 1. Am I correct? Okay, watch my numerator now. So clean, so clean. This is 12x squared minus 3x. What is 4 times, what is this? Square root 3x squared plus 1 times square root 3x squared plus 1. You learn this in your sets. What is square root A times square root A equals to? A. So this is just plus 4 bracket 3x squared plus 1. Can you see? It's so much cleaner. Very easy to manage. So over here, I just tidy this up. 12x squared minus 3x plus 12x squared plus 4. So this will be square root 3x squared plus 1. So my final answer, 12x squared, 24x squared minus 3x plus 4, everything over square root 3x squared plus 1. Both of me and Xing both have the same answer. It's exactly the same. Okay, I leave it to you, okay, to decide which method you want. But I need to take a look at both of them. Okay, side by side. Okay, contrasting like different approach, okay, to the same problem. We look at them side by side. What do you notice? Which method would you prefer? Why would you prefer that method? I'm not saying mine is a better method. I'm just sharing with you that in my personal opinion it's cleaner. Alright? Over here you must be pretty strong in your tidying up your algebra. But I know which one Xing Yao prefer, I know. Which one will you prefer, Xing Yao? The blue one or the black one? Blue one. After you see them side by side, you prefer the blue one? Why would you prefer the blue one? Easier to see, right? Okay, what about Trish? Which one would you prefer, blue or the black? Blue also. Why would you prefer the blue? Looks easier, cleaner. Notice you don't need to because for the one in black, right, the factorization, that factorize when you take out the negative power, the checking, you must make sure you don't make any careless mistake when you expand it out. So that part could be the tricky part. That part could be the part that makes you lose the marks. But if you do it this way, it's really cleaner. Okay? So Lauren, which method would you prefer? Okay. Okay, let's take a look at these questions that your friends have attempted. Okay, I'm not saying what is on the board is perfect, it's all correct, best approach. I'm not saying that, okay? But what I appreciate is the effort, what they do over here on the board. They tried their best based on their understanding. Okay, but I like to point out certain very important things that you used to know, but you have forgotten today. Okay, I'll talk about it later. Okay, let's run through the questions part by part. For the first question, okay, watch here, Serena, watch here, between y equals to x square root 3x, 3 minus x squared. For this particular question, right, the first thought that I think Xingya had was, when she saw this, she thought, this is chain rule. When Xue Wen tried this, the cameraman, that's you, she tried this, she also tried the chain rule. Doesn't work. Then the question is, why is it not chain rule? Why doesn't it work? Okay, you see, girls, so far this morning, right, every question you did now looks like this. Bracket, there's x plus 3 example, then 5x minus 1 to the power of 4. Things like that. Then you dy dx. Then you all knew it was product rule. Am I correct? Yes or no? But for this particular question, right, notice there's no x plus 3, it's just x. So some of you thought then this is chain rule already. That's where you're wrong. That's why I always say you must check for the condition. Whether can you apply chain rule, your product rule to this? Okay, can you apply product rule to this? Let's take a look. If you look at this situation, right, isn't this a product of two expressions? Both of them contain x. Look, this x can be written as x plus 0. So isn't this your product rule already? You understand? Just that it's written in a different form, it will trick some of you because it looks different. So that's why your fundamental understanding, you must be strong, you must be very clear. This is x. Two expressions multiplied together, product of two expressions, both of them contain x. So I can do the product rule. So let u be the first one, v be the second one, and then I happily just differentiate it. So over here, look at how Shini, right? Shini did this, no? Who did this? Ayong. Okay, so Ayong basically differentiate the parts, and then she applied the product rule very nicely. U dv dx plus v du dx. She avoided using the factorization method because it involves denominator and then there's sets involved. So she just, this is the same as over 1. So she times top and bottom by square root 3 minus x squared times top by square root 3 minus x squared, and voila, the numerator has no more sets. Tidy it up, you have this. Michelle, is that okay? Casey, okay? Okay, everybody look here. Look at the third question here, the third one, this one. There is a reason when Jermaine asked me, Mr. What about this question? I intentionally said, I don't want to tell you, I don't want to talk about it, I just want you to try on your own. There's a reason for this question. Can anybody tell me why? Tiffany, tell me why did I give you this question? Wait, Summer, why? Sorry? I intentionally give it because the 5 does not have x inside, right? Purposely no x. I just want to see what will you do. I'm not saying Samantha's approach is wrong. No. The answer is correct. Okay, over here, what I want you to pay attention to do is the approach that she used. Notice what she did was, what I like was, she wrote this, rewrote this as 2x minus 1 raised to the power half. Then she started differentiating. But over here, Sam, when you differentiated this, what did you do? You were using what? The product rule. Am I correct? So u dv dx plus v du dx. Voila, the answer is there, right? But my question is there a need for product rule? There's no need. Not that your answer is wrong, but this is not the best method. I already said before, you can eat chicken rice with fork and spoon, or you can eat chicken rice with a straw. You can suck out all the rice, you can do it, but it takes a long time, it's not efficient. Okay, so over here, if you look carefully, right, let's check the condition. Expression times expression, right? They have two factors, right? Multiply one another, right? But this one is just a number 5. It does not have x inside. So in that case, right, what you can do is you can use chain rule straight away. So this is actually what we did yesterday night. Yesterday. Okay? So over here, differentiate it, just bring down the power. So 5 over 2. Then 2x minus 1 to the power of negative half. Differentiate inside is 2. Cancel, voila, you get the answer already. So this is cleaner. Is that okay, Sam? So this is the correct approach for this question. I intentionally set two questions apart so that no, I just want to distract you. That's all. This one is not chain rule because there's x involved. This one, my friends, is not product rule. This is chain rule. Why? Because the 5 does not contain the x. Jermaine, do you understand now? That's the reason why I don't want to answer you that question. I just wanted you to try, but I want to see, do you know how to apply your understanding? Okay, for the second one, this particular current tool, this is pretty painful. Okay, I don't deny it's really painful. That's why you must be very clinical, very sharp with how you manage your algebra. So let the u be the first expression, v be the second expression, and then you just differentiate accordingly. U dv dx plus v du dx. So please pay attention to what I've shared with Shini. This half over here, right, you can actually write it this way. Instead of writing half, you can write like that. This is the same as your half. 1 over 2 divided by 1. You can bring the 2 down. Okay? So this one is like your 1 over 2. Like that. You don't need the 1 then. So you still have this. Is that okay? Yes. Is there anything about this solution that you don't understand? Michelle, is there any part? Jesselyn, any part? About? Okay? Can yes, Michelle. Which part? Which part? This one? Okay. Over here, right? What is u, my friend? Isn't this u? She wrote it here. dv dx. Isn't this dv dx? Look carefully. This dv dx is, if you rewrite this, it's the same as 1 over 2 square root x plus 1. Can you see? So Shini saw this inside her head already. So she took this whole chart and then put it down. So u dv dx is this. Plus v. What's v? V is this, right? So v. du dx is 3 over 2x to the power of half. That's it. So this is the product rule. Everything else is just tidy it up only. What is LCM? 2 square root x plus 1. So times top and bottom by x plus 1 times square root x plus 1. Voila. Then x square x plus 1 times square x plus 1 by x plus 1. Then x to the power of half. So expand, tidy up. Okay, do step by step. It's painful, but it can be done. Okay? Okay, the last one, how current did it, right? Watch here. Some of you, okay, watch here. Everyone watch here. There are 3 terms involved, right? Three expressions are. Some of you are stumbled. Oh no, mister, does that mean I use product rule 2 times? No, girls. You can collect this into 1. Like what she did. Collect this into 1. So this is u, and then this is v. Can you see how she did it? So this is her u, this is her v. So u dv dx plus v du dx. That's it. So notice how Karen did this question. Notice when she differentiated this, she didn't use chain rule because she recognized this is term by term differentiation. Okay? Now you know how to do term by term differentiation, you know how to do chain rule and product rule. You must know when to use what. When you eating chicken rice, use fork and spoon. Okay, you eating noodles, you use your chopstick. So use the correct approach, the correct tool to manage your situation. So other than that, this part, she just tidy everything up, just write in the form of, she just wrote down what they are, and then she just tidy them up. Like erase off this part. Then it won't be confusing. Okay? So this part is this is this, and then she just basically combine 2 fraction. When you want to combine 2 fraction, make sure the denominator is the same. So this is the same as over 1. So she times top and bottom by square root 5 plus 6x, times top by square root 5 plus 6x, and then you have 6x tidy up. Okay? Is everybody fine? Is everybody doing okay? Michelle, understand now? Andrea, is that okay? Sam?